There we go. I did mention to you guys the other day that I'll record all of our lessons. That way, if you're ever absent, you can go back and look at stuff as you need to, or if you want to rewatch something to study for a test. So you're going to see that like Zoom kind of box around the top part should go away here in just a minute. But that's why you're going to see that up there. So today we are going to talk about inputs and outputs for functions. Which is related to what we did yesterday, right? Yesterday we were evaluating. So I gave you functions and I specified some inputs for you. I specified some inputs for you and asked you for the outputs. That's what we were doing yesterday. Inputs and outputs yesterday with that evaluating. Today, we're going to do the same thing, but the structure of it's going to look a little bit different. So we're going to create some tables for functions. The reason that we're taking some time to talk about this is because it's a tool that we'll use later on in the year, particularly when we get to graphing. Okay, we'll use it for some of our application problems as well, but tables are a really nice sort of one size fits all option if I need a graph of a function, right? We'll talk about general shapes for parent functions. And if I know I have a quadratic, I know it should look like a parabola, or if I know it's a square root function or an absolute value function, we'll get to the point where we have a general idea of what all those shapes should look like. But if I run into a function that I'm not familiar with, that I haven't seen a parent function for, it's helpful to be able to create a table of values. So we're going to start with just a little quadratic function here. And I have not given you any x values this time. So this is a little bit different than yesterday. Yesterday I said plug in or evaluate for f of 3, evaluate for f of -1. Here, I've left it up to you to pick the values that you want. One thing that I want you to think about anytime that you are evaluating or plugging in values, making a table, if we're trying to construct a graph and our table is our way to do that, I want you to think about what x values make sense for this function. So we've got an x squared. Whatever value I plug in for x, I'm going to square it. Are there any values that I cannot square? Are there any numbers that if I try to square them, I'm going to have a problem? The big categories I want you to think about. Can I square positive numbers? Yeah. Can I square negative numbers? Sure thing. Can I square 0? Yeah. Can I square fractions or decimals? Yeah. I mean, is it going to be nice if I square a fraction or decimal? Maybe not. But can I do it? Yes. Okay. So I don't have any restrictions on my input here. I can plug in whatever I want. Okay. I'm generally going to try to pick values that are a little bit friendlier, especially when we're in our graphing unit. I want to pick values that are like going to fit on a graph and be nice and easy to graph. But you can plug in whatever you want. I'm going to choose to plug in values from -2 to +2. If you want to plug in different values, that's okay. But I'm going to choose to plug in values from -2 to +2. Once I pick my values, this is exactly the same as evaluating what we did yesterday, okay? Once I pick my x values that I want to plug in, same thing I did yesterday. So I'm going to plug in -2 for x. So this would be 3 times -2 squared minus 2. And then just make sure that you're simplifying carefully. 9 times out of 10, when I see correct setup for a problem, but an incorrect final answer, it is a silly mistake somewhere in simplifying. Sometimes it's an order of operations thing. Sometimes you just get ahead of yourself and you tell me something like 2 times 3 is 5 instead of 6. So just be careful with that kind of stuff. So as I'm simplifying here, -2 squared is 4, 3 times 4 is 12, 12 minus 2 is 10. And then I'm going to do the same thing for each of these values. 3 times -1 squared minus 2. -1 squared is 1. That's 3 minus 2 is 1. And then same thing for my remaining values. 0 squared is 0. 3 times 0 is 0. 0 minus 2 is -2. When I plug in 1, I get 1. When I plug in 2, I get 10. And then at the bottom, I asked you, does this function have any extreme values? What's an extreme value? In math, what do we mean when we talk about extreme values for a function? Think about a graph in particular. This is not the graph of this particular function, but if this is my example I'm going to work with, what might be an extreme value on this graph? Mm-hmm.
Maybe like the point is all the way at the top of like the first curve.
A maximum? What else would be an extreme value for this graph? A minimum. Minimums and maximums are extreme values. Based on our table that we have here, do we see any extreme values? Anything that indicates extreme values? We sure do. Ethan, where would you guess there's an extreme value? 0, -2. Why? Yeah, if we look at what we're seeing in our y values here, we start with big Y values, then they go down, then they come back up. That indicates an extreme value from my table. Does that make sense? It indicates I've got, in particular, what kind of extreme value? A minimum, yeah. We're looking at a minimum. Example 2, we're going to do the same thing. We're going to create a little table of values here for our function. So this time our function is 2 to the x plus 4. We had a quadratic for example 1. Now we've got an exponential function for example 2. I want to stop for just a second and think about, based on where my variable is now, are there any restrictions on what I can plug in for x? Do I have any restrictions on my domain? So can I plug in positive numbers? Sure thing. Could I take x to the second power, x to the fourth power, x to the fifth power? Yeah, positive numbers are okay. Could I plug in negative numbers? Yes. Now, they're not going to give me like the nicest answers out when I plug in negative numbers, but I absolutely can have negative exponents. That's okay. How about 0? Sure, I can take steps to the 0 power. How about fractions or decimals? You actually can, and we'll talk about those later on. So you guys have not seen what we call rational exponents yet, but you actually can use fractions or decimals here. When I make a table though, I probably am not going to choose fractions to plug in for an exponent, right? That's okay. But I could plug in positives, negatives, 0, all those are fine. I'm going to choose, I think we'll start at -1 and go up from there. If you don't like my values and you want to pick your own, go for it. I'm going to pick these. I am selecting values that make my work to evaluate a little bit easier. That's why I didn't start with -2, because I didn't want to have to do multiple negative exponents, because I'm just not feeling it today. So now I'm going to go ahead and plug in those x values. So 2 to the -1st power plus 4. We talked a little bit about those negative exponents yesterday. Does anybody remember what we said about negative exponents? Yeah, it tells me to do the reciprocal, right? So this would be 1/2 to the 1st, which is just a half plus 4. So we get 4.5, right? 4.5, 4.5. If you want to write it as a mixed number, that's fine too. And now I'm going to plug in 0. So 2 to the 0 power plus 4. What's 2 to the 0? 1. Anything to the 0 power is 1. There's a little sort of asterisk disclaimer when we take 0 to the 0 power. But 2 to the 0 is definitely 1. 1 plus 4 is 5. And then 2 to the 1st plus 4 would be 6. 2 squared plus 4. 4 plus 4 is 8. Then 2 cubed plus 4. 2 cubed is 8 plus 4 is 12. And I could keep going. And then just some review of function notation down here at the bottom. F of 0. I asked you questions like this, stated like this yesterday. I asked you what's f of 3 for a bunch of different functions. I asked you what's f of -1 for a bunch of different functions. And you had to take that value and plug it in. But I want to talk about how we get that from a table here, because I don't need to plug it in again, right? We already have that information. So if I want f of 0 from a table, or f of anything from a table, I'm looking at that value as an x, and I am going to report that corresponding y. So f of 0 here is 5. You will also have questions from me where I give you the output and ask you for the input. So like our second question down here, find f of x equals 4. Now, this could be a function or a question where I take my function, I set this as the output, and I solve algebraically for what that x value was. But if I have a table of values, we can take advantage of that table. We've already got a bunch of input-output pairs, right? So when my y value, my output is 4, do I have that in my table? No. If I asked you what's f of x equals 6, right? This one would be a little bit easier. We would go to 6 and you would tell me x equals 1. I'm asking for 4 this time. So I didn't get that because I started my table at -1. What could I do to try to find it? Anybody have a guess where it's going to be? Try -2. Let's try it. Let's try -2. So this would be 2 to the -2nd power plus 4. So remember, this is going to be reciprocal. So this would be 1 over 2 squared plus 4. So that would be 4 and a fourth, right? 4.25. Not quite. Why not? Very good. So did we hear that? I know the air conditioner is kind of loud. Okay. So if I plugged in -3 here, right? I could try. I could keep plugging in smaller and smaller and smaller numbers. But what I'm plugging in is an exponent, right? So it's going to be 2 to some power. And when I take it to a negative exponent, that's the reciprocal, right? So it'd be 1 over 2 cubed, or 1 over 2 to the 4th, or 1 over 2 to the 5th. And I could keep going, but this is not 0. It's a small number, but it's not 0. Okay. So when I add it to 4, that's already here, it's always going to be something bigger than 4. So a minute ago, or a couple minutes ago at this point, I said we just need to keep an eye on what kind of values it's okay to plug in for x. Okay? And I can plug in whatever I want for x. The other thing that we want to be aware of is, what is our output going to look like? Are there any restrictions on the output, on the range here? Am I ever going to be able to get down to 4 plugging in values for x? No, there's nothing that I can plug in here that's going to make this be 0. So this is not possible. No value for x bless you, will give f of x equals 4. What's happening, and we'll talk about this when we get to our graphs in a little bit. What's happening is I'm graphing an exponential function, or I'm looking at values for an exponential function, and 4 is where my asymptote's going to lie. If you remember exponential functions from Algebra 1. Okay, we've done a couple together now. I want you to try example 3. I want you to fill the table. So I want 5 input-output pairs. And I want you off to the side to let me know, were there any values that you cannot use for the input, or are there any values that you would not see in the output for this function? So start with your table. selecting X values, I want you to remember that nowhere in your directions does it say each value. You don't have to, or consecutive, I should say, you don't have to select consecutive values. So if you are making a table and 3 is gonna be a really messy value to plug in, it's not gonna give you a nice output, you can skip over 3. Or if you have maybe a couple of values that are gonna give you not so nice outputs, it's okay to skip them and be selective with your input values. That maybe doesn't matter so much for this one, but for some of your other functions, you might want to be a little more selective. So as I'm going to set up my table, are there any values that I need to exclude from my input? Is there anything I cannot plug in for X? Everything's okay to plug in? Yep, I can plug in anything that I want. Okay. What kind of values did you guys choose to plug in? Did anybody plug in something negative? Okay. Anybody plug in 0? Anybody plug in positive values? Okay. On mine, I'm going to go from -2 to +2. Did anybody pick that same range of values? Okay. Anybody pick that same range of values because it's one I picked for an earlier problem set? Okay, that's fair. I like to pick a little bit of everything that I can. That way I get kind of an idea of a general shape when we're going to graph. So if I can plug in negative, I usually plug in a couple negative. If I can plug in 0, I usually do. If I can plug in something positive, I usually do, unless I have a good reason not to. If you plugged in -2, you should have gotten -19. That look good? Okay. -1, did you get -8? Cool. 0, you get 1. Thank you. I was waiting for somebody to say no. What should I get? -3. There we go. Just making sure you're paying attention. What if I plug in 1? What should I get? 2. How about if I plug in 2? 13. There we go. Okay. And now output. Is there anything that I will not get from the output? Any Y values? It is impossible. Like the last problem, it was impossible to get 4. -23. Is that based on something or?
I'm just assuming.
Why?
Because the I asked the it was a happy mistake.
Oh, because there was an error somewhere and it gave you -23. So now we think -23 is like poison.
Yeah.
Okay. Probably not, right? This is the cubic function. I like the thought that went into it though. This is a cubic function, right? So it's going to look something like this. Okay. Which means we know our input can be anything. It also means we're going to go forever down. We're going to go forever up. We'll talk more formally about end behavior a little bit later when we get to our graphs. But if I can go down forever and I can go up forever, there are no holes, there are no asymptotes in this graph. Are there going to be any output values that I cannot have? No. Are there going to be some that are going to be maybe difficult to get, like potentially -23? Sure. Okay. But no restrictions here. So I want to review some notation with you. I'm not sure what you guys saw previous to this class as far as set builder versus interval notation for things like domain and range. But if we talk about our input, our domain, anything goes, right? And as long any real numbers, good to go. I can plug in anything I want. There are 2 ways that we could describe that. And throughout this course, we'll practice both. This is what we call interval notation, anything from -infinity to +infinity. Okay, fair game. That means all real numbers, fair game. We can also write this with inequality symbols. -infinity is less than X is less than infinity. X has got to be somewhere between whatever value I pick for X has to be somewhere between negative and positive infinity. And then our output, since it has no restrictions, same idea. I can use interval notation. or we can use that inequality notation. This time though, in the middle is Y, because we're talking about output. Talking about range. Questions for me so far? Okay, on to the next page. For our next example, we don't have a function. Instead, we have a context. Okay, I'm describing something to you. So for example, 4, a colony of bacteria has an initial population of 3 and doubles every hour. Create a table of values that shows the population growth over a period of time. So I know my population starts with 3. So I'm gonna put that as my first output value in my table. What would be a time that would make sense to correspond to that? 0, yeah. Where am I starting? And then when we talk about time, that input in this case, as I'm sort of counting, it's telling me my population doubles every hour. So what might be nice values to use here? Positive whole numbers, right? 1, 2, 3, 4, okay. Could I consider or look at the population every half hour? Sure. Could I? Sure. Could I look at it every 15 minutes? Sure. Sure. Could I look at it every 27 seconds? Sure. Do I want to though? No, not really. No. So I'm going to pick again values that make this problem a little bit easier for me. So 1, 2, 3, 4, and then my population doubles every hour. So in 1 hour, I'll have in 2 hours,
12,
in 3 hours,
24,
in 4 hours.
48.
Okay. No function this time, but we can still create a table based on the information that we have, that description that we have. So we talked about this one already. What type of input values make sense? We selected positive whole numbers. We also said they don't have to be whole numbers, so I just need positive real numbers. We could say we want x greater than or equal to 0. We could use interval notation with a bracket at 0 this time, since we can include 0 in that range of values for our input. How about output values? What kind of numbers am I going to get here?
Positive real numbers.
Positive real numbers. Is there a minimum I need to consider? 3, right? Positive real numbers greater than 3. And then I want you to think about the context of this one too. We're talking about bacteria. Any real number? Whole numbers on this one. Yep. Got to be whole numbers on this one. So positive whole numbers greater than or equal to 3. And then the last couple here should be pretty easy because we've already talked about these. How many bacteria are present after 3 hours? Yeah, you have a table that tells you. Give a reasonable estimate for how long it will take the bacteria population to reach 20. Bless you. 20 is not in here.
2.5 hours.
Somewhere between, reasonable estimate, somewhere between 2 and 3 hours, yeah? Okay, 2 is not enough. 3 is, I've got more than that many bacteria already. Somewhere between 2 and 3. If I made you narrow it down more, would you skew closer to 2, closer to 3, right in between the 2?
No.
Close, sorry. Who's going closer to 3? Who's going closer to 2? Okay. My closer to 3 people, that was the majority. Why closer to 3? Yeah, right? So could we figure out the exact time that I'd get 20 if I had a function? Sure. I could put this in my graphing calculator and come up with a regression equation, and we will do stuff like that later on. For today, I just want between 2 and 3. But closer to 3. And then some function notation thrown in there for us again. We'll continue to review and use function notation throughout Algebra 2. Find and interpret f of 2 in the context of the problem. So first, find f of 2 for me. What is f of 2? Yeah. Input, output. I know the input is 2. My output then is 12. What does f of 2 equals 12 mean for this particular scenario? What's it telling me?
After 2 hours, it's 12 back to 0.
Perfect. Find and interpret the interpret part in the context of the problem. What we're looking for, what are the labels that go on these numbers? 2 what? 12 what? After 2 hours? There are 12 bacteria. We're going to skip example 5 on the next page for right now. I want to talk about example 6. Okay. So we're still talking inputs and outputs. This time I've given you a graph. So we've looked at this with tables so far and created our own tables, used those tables both from a function and from a context. Now I want to talk about input and output from a graph. Okay. So I've got the graph of a rational function here, and I'm asking you to evaluate f of a few different values, and then to actually figure out what would be the input if I've given you the output. Okay. So when I'm doing this with a graph, remember that this is the same as yesterday. When x is this value, what's the output? So when I do that on a graph, I'm going to go to where my x value is 0, and then follow that to the graph and report what that output is. So f of 0 is -2. That's the y value there. Just a different representation for the same thing we did yesterday. Okay. F of 4 means I go to where my x value is 4, and then I report the output, the corresponding y value. We're going to have to estimate on a couple of these. That's okay. So I'm going to say this one is about a half. Does that seem reasonable? And then f of -2, I'm going to go to where my x is -2, follow that to the point on my graph, and report the y. My y is 0 there. Not too bad. For the other ones, I'm giving you the output. You're going to tell me the input. So these are y values. So I'm going to start by finding that value on the y-axis. So when y is -4, what are the x values? What are the inputs that could have given me that? What do we see for this one? There's 2, right? If you have more than 1, you report all the ones that you can see. Okay, so in this case, we can see 2. So I'll report those 2 values. And again, we're approximating here. That's okay. So what do we think those x values are? Approximately, you're missing one thing there. There we go. Negative, I heard 0.8 and 0.9. So I'm going to split the difference and do 0.85. And then how about our other one?
-5. No, +5, my bad.
About a half. About a half. Ish. -1. When y is -1, what do we see? Nothing. Nothing. So what do I write here? No, question mark. None. Undefined. When we get into talking about rational functions, we'll talk about how that means that there's an asymptote here, and what that means in the particular function. I didn't give you the function this time, so we can't sort of point at why there's an asymptote here. But we can write none or undefined. Somebody said no solution. When we go to solve, if I got something like this, that would be a no solution situation. And then how about 3? We've got to estimate again. That's okay. About what and about what? Negative 1.1, did I hear? Okay. And then 1.5? Sure, that works for me. On the next page, we've done all these things separately. Now let's do them all together. So you have 3 different functions here. One of them I called f of x. The one in the table I called g of x. And then this guy I called h of x. So be careful, pay attention to what function you're looking at. And then you are just giving me those corresponding inputs or outputs, okay? So take a couple of minutes, work through example 7, hold off on example 8 for just a minute. Okay, let's take a look at these. For A, g of 2. So first, make sure you identify the correct function. G is our table. And then we have an input, g of 2. So when the input is 2, the output is 0. B, f of negative 4. F is our function. So this is what we did yesterday. I'm evaluating when x is negative 4. So negative 1/2 times negative 4 plus 4. Just make sure you're careful with your order of operations. This would give me positive 2 plus 4 is 6. C, we want to use H, which is our graph, but this time I gave you the output. So when our Y value is negative 2, which is down here, what are all the inputs? In this case, I said all the inputs, right? Because we've got multiple. Some estimating here, that's okay. I would say you should have approximately maybe negative 0.75 or negative 0.8, okay, for here. We've got 1, and then we've got approximately, let's say maybe 2.75, 2.8, something like that. Looks like it's a little past a half. So I'm selecting something a little bigger than a half. What'd you get for D? Yeah, Yeah, negative 22. This was our function again. I gave you the output. So that means we're going to set our function negative 1/2 x plus 4 equal to 15 and then solve for x. So negative 22 there. How about G? 2. Your output is 0. So that input had to be 2. And then F, H of 0. H of 0 is 0. Yep. When your x is 0, your y is 0. Okay. Last one for today, example 8. Now I'm asking you to give me some comparisons. So greater than, less than, equal to, how do these compare? So G of 2 compared to H of 2. Well, G of 2 is 0. H of 2 is negative 4. So G of 2 would be greater than H of 2. Does that make sense? What I want you to do for that last section? Okay, using the same functions of that. Go ahead and finish example 8, and then I want you to compare your answers with a neighbor. When you are done, your homework for tonight is on Delta Math. Okay, it's labeled L2 since this lesson was L2. So it should be easy to figure out what your homework assignment is. It should be also the only one popping up for you so far. But your homework for tonight is on Delta Math once you finish example 8 and check with a neighbor.